Hi, everyone. Welcome to our Tech Talk, where we are going to talk about enhancing your Amazon RDS for MariaDB databases with MariaDB 10.6. My name is Komal Pal. I'm a product manager, and with me, I have Vijay Karumaji, who is a specialist solutions architect at AWS. And we are going to talk about some of the new features that we have introduced in Amazon RDS, as well as new features and functionality introduced in the community version of MariaDB 10.6. Our agenda for today, we'll start off with the enhancements that have been made to Amazon RDS for MariaDB, followed by a short demo and the community MariaDB 10.6 major enhancements. And we'll close with why you should run a managed MariaDB service on Amazon RDS. So let's jump right in. I'll start off with the Amazon RDS for MariaDB enhancements. In Q1 of 2022, we introduced the new version MariaDB 10.6 with Amazon RDS. And with that, we enabled several new features. We have also introduced delayed replication as a disaster recovery strategy. We've expanded our portfolio of storage engines on RDS MariaDB, and we've added MyRocks along with InnoDB. We have also introduced one-step major upgrades, which are also known as multi-major version upgrades. And finally, we've added integration with the AWS Identity and Access Management Service, which is more frequently called IAM. In the next set of slides, I'm going to go over each of these features in a lot more detail. Let's start with delayed replication. Now, what is delayed replication? Delayed replication is a way for customers to set a configurable time by which a replica lags behind the source database. Why would you need that? It's typically used as a disaster recovery strategy. So, as an example, let's say you accidentally deleted a table on your primary or the source database. You can recover from that by stopping your replication and promoting your read replica to be the new source database. Because you had configured a delay between the source and the replica never experienced the table deletion. Now, a couple of things to note here. Delayed replication on Amazon RDS is managed through stored procedures. It cannot be configured through the management console or the CLI or the API. So let's get into how to set up delayed replication on your RDS MariaDB instance. If you're setting it up for a read replica while you're creating the read replica, all you would need to do is call a stored procedure called RDS set configuration. And what you need to pass to this procedure is a target delay in seconds. So for example, the first example we have here is a delayed replication setup during a read replica creation for 1 hour. So we pass the target delay parameter, a value of 3600, which is 1 hour in seconds. If you wanted to configure delayed replication on an existing read replica, what you need to do is first stop replication by calling the RDS stop replication procedure. Then you can set up a lag on the replica by calling the RDS set source delay, and once again pass it the value of the delay in seconds, 3600 in our example. And then you can restart the replication by calling the RDS start replication procedure. If you have any questions about delayed replication, we are happy to take those in the chat or save them for the end of the session where we'll take Q&A. Now, let's talk about the next new thing. We've expanded the storage engine portfolio for MariaDB on Amazon RDS by adding the MyRocks Storage engine. Now we have two storage engines that are supported on MariaDB, that are InnoDB and MyRocks. MyRocks is an open source storage engine which was originally developed by Facebook, which added RocksDB to MySQL and to MariaDB. The difference between InnoDB and MyRocks is the architecture. MyRocks uses the log structured merge architecture, whereas InnoDB uses B plus tree. And this difference in architecture results in several benefits which are specifically obvious for write intensive workloads. Now, what are these benefits? Let's talk about each of them. The four benefits that we observe while using MyRocks are greater space efficiency, which means you use less storage because of the better compression that MyRocks offers over InnoDB. You can also get greater writing efficiency, which means you use less I/O for write-intensive workloads. You can do faster replication because MyRocks doesn't need to update secondary keys and doesn't need read random reads associated with those. And you can also achieve faster data loading due to just lesser compaction overhead with MyRocks. Now, of course, the actual gains that you will see for your specific workloads are dependent on the workload itself, as well as your parameter configuration and the infrastructure that you're running behind it. MyRocks storage engine is available on Amazon RDS for MariaDB 10.6 and higher. How to set up MyRocks? It's very straightforward. You define the storage engine that you use while you're creating your tables. So as part of the create table command, you would pass engine equals rocksdb, and that will change the storage engine from InnoDB to rocksdb. By default, Amazon RDS for MariaDB will always default to InnoDB. Now, a couple of notes here. MariaDB does not guarantee ACID for transactions that span storage engines. So we recommend that you do not use transactions that would span both InnoDB and MyRocks tables. And secondly, MyRocks does not support serializable isolation or cap locks, which means MyRocks cannot be used with statement-based replication. If you want to use statement-based replication, we recommend that you use InnoDB. The next enhancement to Amazon RDS for MariaDB is a feature called multi-major version upgrades. So previously, if you wanted to go from an old version of MariaDB, let's say version 10.4, to the latest version, which at the time of this recording is 10.6, you would have to do that in two steps. First, you would have to go from 10.4 to 10.5, and then you would go from 10.5 to 10.6. With the multi-major version upgrades, we've made that easy by making it a one-step upgrade, which means you can go directly from 10.4 to 10.6 in a single step. And this is supported for any older version that's available on Amazon RDS for MariaDB. So you can go from 10.2 or 10.3 or 10.4 or 10.5 directly to 10.6. This avoids customers from having to take multiple downtimes associated with each incremental upgrade. A note of caution as we're talking about upgrades, always test before making any major version upgrade. You can do that by running an assessment using the MariaDB check upgrade command. And also, after the upgrade, make sure you've tested your application with the upgraded major version before you deploy anything to production. And finally, let's talk about the latest new feature, which is identity and access management integration with Amazon RDS for MariaDB. Now, AWS IAM provides fine-grained access control across all of your AWS resources. It allows you to specify who can access which services and which resources under which conditions. This is all managed via a policy-based mechanism. Customers can define least privilege permissions by setting up their policies in the way that's appropriate for them. IAM allows you to centralize all of your access management in one place for all of your AWS resources. IAM is currently supported with Amazon RDS for MariaDB 10.6.5 and higher. If you want to set up IAM on an existing RDS MariaDB instance, you would just call a modify DB instance command and enable IAM database authentication on it using a command shown on your screen. To do this, it will not require any downtime and is applied almost instantly. To see how this works in practice, I'm going to hand over to Vijay, who's going to walk you through a demo of how IAM can be configured on an actual RDS MariaDB instance. And we are going to follow that up with some new enhancements that have been made in the MariaDB 10.6 Community Edition. Over to you, Vijay.
Thank you, Komal. As part of this demo, we're going to do the 6 steps. First, we're going to enable the IAM authentication on the MariaDB RDS instance, and then we will create a database user account that uses the AWS authentication token. And then we will create an IAM user. But if you would like to try it with IAM role, you can do it with IAM roles as well. So we will create an IAM user, and then to that IAM user, we will add an IAM policy that has a tight integration with our database user. And then we will generate an AWS authentication token. That token will act as a password for that database user. And then we will connect to our RDS MariaDB instance using IAM authentication. So let's get started. On screen, we have an RDS MariaDB instance, which is on 10.6.7 version. And to enable IAM authentication, you can enable it by simply using AWS console by clicking the modify, or you can use CLI or API calls, right? So I have already enabled the IAM authentication on this instance. So let's check under the configurations. You can see IAM authentication is already enabled. If your RDS instance is not enabled with IAM authentication, simply click on modify, and under the database authentication section, select the password and IAM database authentication option, which would enable the IAM authentications, where you can leverage IAM users or roles to connect to this RDS instance, right? To enable IAM authentication, it does not require any reboot, so it is simply a dynamic change. So with that, let me come out of it here. And then next step, let's create a database user. For that, I'm going to use an RDS instance. Let me connect to that RDS instance with my master user credentials. Now let's create a DB user. So in here, I have created a MyDB user. And then in the create DB user syntax, if you see, right, identified with authentication plugin as RDS. So which means this DB user is going to use IAM authentication feature. And then let's also make sure this user only can connect using SSL connections, because IAM authentication requires an SSL connection. Now let's provide some permissions to this MyDB user. So here, as you see, I'm just providing the select permissions. Now let's verify what we have created so far. For that, I'm going to query our MySQL user table. Just to show you, we have created a MyDB user, and the MyDB user using plugin called AWS Authentication plugin, which means this user is using IAM authentication. And then let me also show you the databases that we have. And for this demo, I'm going to use MyLab. And now let's see the tables that we have. And we have a table called speakers. Let me quickly show you what we have within that. So in the speakers table, we have Komal and myself, right? And today's speakers. So let me exit out. Let me clear this out. Now let's do step 3 and 4. Let's create an IAM user and attach a policy that maps the database user that we created in step 2 to this IAM user or a role that you create, right? So for this demo, I have already created an IAM user. So under Identity Access Management Console in IAM, you can see under users, you can see an user called IAM user. And then this user already attached an IAM policy. So I just want to show you how this policy looks like. And as you see here, the policy has a resource and a statement. In the statement action, it can do RDS connect, and then resource is, this is the resource it can connect to, right? So let's see how the resource string looks like. So in the resource string, what you have is a region and then account ID, and then DBI resource ID and a DB username. So as we know, our region is US East 1, or the region that you have your RDS instance, and the account ID that your RDS instance is running under, and DBI resource ID, which is nothing but your RDS MariaDB resource ID that you will get it from the configuration tab of the RDS instance, and then DB user that we created in the step 2. So once you have all this configuration for your resource, then attach that policy to your IAM user. So for part of this demo, I have already attached policy, but this is an example policy that I would like to show you here. So that is the same policy that we discussed. I have attached it with all the updated information. Once you have it, now let's see what we need to do. We need to generate authentication token, and then using that authentication token as a password to our DB user, we're going to connect to the MariaDB instance. Now, as first step, what I'm going to do is I'm going to create some environment variables that I'm going to use as part of the connection string to connect to RDS instance. So I exported the RDS instance connection string into the RDS host. Now I'm going to generate the token. So if you look at here, right? So I'm just creating a token. This token is using AWS RDS generate DB authentication token CLI. So if you're using IAM authentication in your application, then you need to make sure you generate with generate DB authentication token CLI. This requires a host as a input, and then port number, and the region, and then my DB user, right? So the DB user that requires that we're going to use it as part of the IAM authentication. So which I have generated, and now it is in the token environment variable. So let me quickly show you how that does look like. So this is how that token looks like. It is quite a huge string, right? I cannot use this whole string as part of my connection string. So that's why I'm using the environment variables to save that password. So here the good part is, right, this token valid only 15 minutes. So this is the additional layer of the security that IAM authentication provides to you. Now with the token, now let's connect to our RDS instance. So as you see here, I'm using the host as RDS host, and the port number, and then DB user that we created, and the password as our token, and then which requires an SSL. As IAM authentication requires some SSL connections, we need to make sure we have an SSL equals to 1 if you're using command line arguments. So now let's see, we are successfully connected to RDS instance using the IAM configurations. Now quickly, let's see the databases that this MyDB user can see. So you can see my labs are there. So let's use my lab and then see the tables. In tables we have speakers. Now let's quickly query that to make sure we have permissions to read those tables. This MyDB user can read that. So if you quickly want to test to see if you can insert anything. So I'm just making sure, try to insert a dummy record into that speakers table, and you cannot insert any records, because when we created this MyDB user, we just provided the select permissions. So that is another layer of security you can use for your users. So you have two layers of security. One is that the password is only valid for 15 minutes, and the second layer of security you can use is the permissions that you create for your uh, database users. With that, the demo is done. So let's get back to our presentation.
So now let's look at enhancements in MariaDB 10.6 that brings to the table. Here we put together some of the enhancements in MariaDB 10.6. Some of them are Oracle PLSQL compatibility, new JSON table function introduced for the first time in MariaDB 10.6. Atomic DDL feature is added for reliability. Syschema is introduced for monitoring and troubleshooting purpose. For performance, MariaDB introduced ignored indexes and some inbuilt InnoDB enhancements. Let's dive deep into these enhancements. Oracle PLSQL inbuilt compatibility is introduced in 10.3. With MariaDB 10.6, there are additional functions being added here. If you see on the screen, right, we have add month Oracle function. This function is used to add, subtract months from a given date or date time value. It is very similar to a date add function in MariaDB. That toChar supports date time, timestamp as parameters and returns a formatted, converted text value for us. And the next one is sysguid, is a Oracle function, which is similar to UID function in MariaDB, which is universally unique identifier. And row number is another function that returns a number for each row extracted from a query. So all these functions are available in MariaDB 10.6. If you're coming from Oracle to MariaDB, all you need to do is use SQL mode in RDS MariaDB parameter groups. If you configure that SQL mode to Oracle, the existing code that you're running on Oracle will seamlessly work on MariaDB. The next one is JSON table function. JSON table function is the first table function in MariaDB server. Before MariaDB 10.6, if you wanted to return a JSON file into a tabular format, what you have to do is you have to use JSON value, which allows you to retrieve scalar values. And then you have to use JSON query, which allows you to retrieve JSON objects within MariaDB to get the job done for us. But with this JSON table function, that transforms the JSON data into relational table so that JSON data can be queried and joined with regular tables. And JSON table function can be used within select statement that I'm going to show you a simple example on the next slide. You can write the JSON table function in your from clause within a select statement. JSON table function can be used in the multi-table syntax of the delete and update statements as well. However, there is when you write a JSON table function, it always requires a table alias. So let's see how it looks like. Here is an example. I have a simple table which has an ID and a name, and a pets is a JSON format. It takes this table, right? And we insert a row which has the JSON file information. And then when you look at the select statement here, right, whenever we're calling the JSON table function, all we need to do is call out those alias names as PT and then refer that in your from clause within the select statement. And then once you do that, your results will be in a tabular format. So to achieve the same thing before 10.6, you have to use JSON query and JSON value functions, right? So this made it very pretty simple to query any of the JSON data that you have within your database. Next one is atomic DDL. MariaDB 10.6 introduces atomic DDL. Atomic means that either the operation succeeds and is logged into the binary log file or completely reversed. Crash safe means that in case of a crash, after server restarts, all the tables are consistent. There are no temporary files on the file system, and there are no data within the binary log files. So with 10.6, you can do create, tables, views, sequences, triggers. These are all atomic functions now. So either they are completely uh, completely fully executed, or it will be completely reverted to its original state. And then if you see drop table and replace table and drop database are class safe functions. So the storage engines that support atomic DDLs are InnoDB, MyISN, and MyRocks DB storage engines that support fully atomic DDLs. MariaDB 10.6 introduced a very exciting uh, schema for database administrators, which is a sys schema that is added in 10.6. This helps administrator to get insights into the database usage for troubleshooting or any of the analytics. If you want to see how your systems are running, if you want to do some analysis, you can query the sys schema, which gives you collection of views, functions, and stored procedures. So if you want to use schema in RDS MariaDB, what you need to do is you need to enable performance schema within the RDS parameter group, turn it on, and then you will see schema would start collecting all the data that is required for you to troubleshoot as a DBA. Next very exciting feature that introduced by MariaDB 10.6 is ignored indexes. The optimizer will treat ignored indexes as if they don't exist at all. They will not be used in the query plan or as a source of the statistical information. So that's why they are pretty safe to ignore them. So whenever you're planning on deleting an index, right, the first thing what you want to do is you simply mark them as ignored index, and then you monitor your health of your workload. And if everything works as expected, then you can simply drop those indexes, right? That is the one of the use case with these ignored indexes. I'm going to show you how it looks like. But another thing what I want to point out here is tables with primary keys cannot be ignored. So that is one thing you may want to make sure before you're trying to make them ignored indexes. This is how it looks like. So here in this example, we are creating a table with two columns, one primary key, other with an index of K1. If you see, I'm simply altering the table and then saying alter index K1 is ignored. When I say that ignored, and if you execute the execution plan, if you look into the execution plan, where you see the use file sort, that means we're not using any more index. In this scenario, we're using file sorts to execute this query. And if you see the next one, alter table one, index K1, not ignored. When you not ignored that, then you realized you need this index because your performance was bad. So you want to enable it again. You can say simply not ignored. When you do that, your query start using indexes. As you see on the screen, we are using the index in the execution query plan. And then some of the other improvements I want to call out here is optimization to speed up inserts into an empty table, which is dramatically improved if you're trying to do an bulk loads within an empty table. Performance improvements are really good with MariaDB 10.6. And then there are some enhancements around temporary table space is omitted from the buffer pool flush list, so that whenever when because of this improvement, right? So you don't see any orphan tables within the storage subsystem. And there are additional improvements around InnoDB deadlock detectors. With that, I'm going to pass it on to Komal, who is going to talk about why run MariaDBs on Amazon RDS.
Thank you so much, Vijay. Now, in the last section of this presentation, let's talk about why you should run managed MariaDB on RDS. Let's start with why Amazon RDS. Now, what you have on your screen in front of you is a snippet from a 2020 IDC report, which captures the benefits that customers have received when they moved from an on-premise or hosted and self-managed environment to Amazon RDS. As you see on the top left section of this slide, customers saw about 39% lower cost over a period of 3 years. In addition to the cost benefits, RDS customers were also able to improve their staff efficiencies and spend time on innovating and optimizing their applications and capabilities instead of operational headaches. With Amazon RDS, backups, snapshots, scaling, high availability, and upgrades are all handled with a few simple clicks, leading to this improved staff efficiency. Who uses Amazon RDS? Hundreds of thousands of customers. A small subset of that is presented in front of you. I'm going to talk about one specific customer out of these called Traveltek, which is a customer based in the UK. Traveltek, as the name suggests, is a travel technology company that connects travel booking agents with suppliers in the travel and tourism industry. They were facing an aging data center and they needed more elasticity and scalability to be able to manage the volatility that the travel and tourism industry is constantly faced with, which has been more pronounced in the last few years than ever. Together with our AWS partner, Cirrus HQ, we help them migrate their data center to a fully cloud based architecture on AWS, including Amazon RDS for MariaDB. This helped them avoid not only a six-figure cost of hardware, but also improved their application page times by up to 50% and saved their employees time, which they were spending on self-managing their hardware to focus on the things that mattered most, which is innovating for their customers. With that, if you want to learn more about Traveltek and how AWS and Amazon RDS for MariaDB help them achieve these benefits, please refer to our publicly available case study, the links to which we'll provide at the end of this presentation. Now, what does Amazon RDS for MariaDB offer as a managed service? The benefits can be broken down into four categories. Amazon RDS offers availability and durability for all of your MariaDB workloads through features such as multi-AZ, read replicas, and auto backups. We offer performance and easy scalability with both compute and storage. We offer easy administration where you can manage and monitor all of your resources with just a few simple clicks or API calls. And finally, security and compliance, which are offered via network security, IAM, encryption, and a support for a variety of industry standard compliance protocols. Let's talk about each of these in detail over the next few slides, starting with availability and durability. Now, Amazon offers RDS multi-AZ deployment, which offers enhanced availability and durability for database instances, which makes them a fit for production database workloads. Each availability zone runs its own physically distinct independent infrastructure and is engineered to be highly reliable. With RDS, you have the benefit of running your primary and your standby in two physically distinct availability zones. Whenever a failure happens, RDS will manage the failover automatically and make the operations resume as quickly as possible. Since the endpoint for your database instance will remain the same after failover, your application can resume operations without any manual intervention required. The next feature here that we're going to talk about is RDS read replicas. RDS makes it easy for you to create read replicas of your database and automatically keeps them in sync with the masters. Read replicas provide two benefits. One, read scaling so that you can relieve pressure from your primary source database. And two, you can use it in disaster recovery use cases. With RDS for MariaDB, you can set up the read replica as multi-AZ, allowing you to use the read replica as a DR target. When you promote this read replica to be a standalone database, it will already be multi-AZ enabled. Another availability and durability feature that RDS offers are automated backups. With RDS, you get one scheduled backup a day, and you can choose what backup time window is appropriate for you. RDS backups your files as well as your transaction logs. And in order to ensure durability and availability of your backups, RDS will keep multiple copies of your backup in each availability zone where you have an instance deployed. And finally, if you want to set up your own backups, we offer the option of snapshots. Snapshots are user initiated backups of your instance that are stored in Amazon S3 that are kept until you explicitly delete them. Although these database snapshots serve operationally and as full backups, you are only billed for incremental storage use because snapshots are always incremental. You can also copy your snapshots across accounts and regions for additional DR. The next set of features is related to performance. The RDS currently offers about 25 instance types that you can choose from to find the best fit for your CPU, memory, and price requirements. You can also scale your database compute and storage with just a few clicks or API calls. You can scale up to as much as 128 vCPUs and 3900 gigabytes of RAM, or scale down to as little as 1 vCPU and 1 gigabyte of RAM. Recently, RDS also announced Graviton 2 instances, which are based on the custom built AWS Graviton 2 processor with 64-bit ARM Neoverse cores. These instances have been seen to achieve up to 52% better price performance on Amazon RDS. Graviton 2 is available both across our general purpose category of instances as well as memory optimized instances. And do look out for free tier coming soon on Graviton based instances, which you can try out all of your RDS MariaDB workloads on. Moving on to the ease of administration, RDS makes it easy to go from project conception to project deployment. Hardware provisioning, patching, backup restores, scaling, and high availability are all accessible within a few button clicks or API calls. With RDS, you get a collection of 15 to 18 monitoring metrics that are automatically available to you, which can be viewed in the RDS console, CloudWatch, or via the CloudWatch APIs. You can keep an eye on metrics like CPU utilization, memory, storage, and latency. You can either view the metrics through tools that Amazon provides, such as CloudWatch, Enhanced Monitoring, or Performance Insights, or you can pull the metrics into your own monitoring tool. And last but not the least, security and compliance. RDS makes it easy to control access to your database at multiple levels. Network security is provided via Amazon VPC security groups. Resource level permissions can be controlled through AWS IAM. Data encryption is available through integration with AWS KMS or Key Management Service. And finally, compliance and assurance programs for various industries like finance, healthcare, government that are all managed by RDS for our infrastructure. Let's talk about each of these in a little bit more detail. First, network level access is secured via VPC security groups. A VPC security group allows you to specify access rules for your MariaDB database instance. Each rule is a combination of three things that you see here in the table before you. There's protocol, port range, and source. The source can either be a CIDR block that covers a range of IP addresses, or it could also be another security group. This gives you the flexibility to have a multi-tiered architecture for your database access. At a resource level, you can restrict permissions using an IAM policy. We spoke a lot about IAM through the demo and the previous part of the presentation, so I won't go into it in much detail here. But if you have any questions, please drop them in the chat or hold them until the end of the presentation where we'll take Q&A. Finally, encryption of data at rest is provided through integration with AWS KMS or Key Management Service. KMS uses industry standard AES 256 encryption to protect your data stored on the underlying host that your RDS for MariaDB instance is running on. The great thing about KMS is that all of the keys are tied to your AWS accounts and are fully managed by you. KMS thus provides an additional layer of protection against unauthorized access to the underlying storage for your RDS MariaDB instance. And finally, let's talk compliance. AWS takes responsibility for compliance of the RDS service and the infrastructure related to it. And you, as the customer, take responsibility for your application on AWS. RDS for MariaDB is authorized for several compliance protocols, as you see listed on the slide in front of you. This includes FedRAMP, PCIe, HIPAA, UK government programs, etc. You can take the audit findings from your application and combine them with the appropriate attestation from AWS's third-party auditors to have a complete verification for compliance for your application on AWS. You can also check the compliance service scope link that we've presented at the bottom of the slide. This will help you find out whether a specific compliance protocol is supported or not against any AWS service that you want to use. And before we close and move on to the Q&A, I'm going to share with you a list of resources that we've compiled to make it easy for you to use RDS for MariaDB. We have a bunch of links, customer case studies, blogs, and also a link to some free digital trainings through the AWS Skill Builder platform. If at the end of this presentation you still have questions about Amazon RDS for MariaDB or you want to reach out to us, we suggest you post your questions on the Amazon repost platform and make sure to tag them as MariaDB so that the questions make it all the way directly to us. With that, I'm going to stop the presentation and open up the floor for questions. Thank you so much.